Welcome all to this video session. I am Dr. D. BHAKIARAJ, working as an assistant professor in St. Joseph's College of Arts and Science Autonomous, Cuddalore, in Department of Chemistry. So, in the analytical techniques theory paper for the third year chemistry students, in the unit 1, there is a topic called IR spectroscopy. Today we are going to discuss about it. Before entering into the topic, what is spectroscopy? The definitions for spectroscopy is nothing but it is a branch of science that deals with interaction of matter with the light or electromagnetic radiation. Various electromagnetic radiation, when falls onto the matter, the substrates or the samples will react based on the energy received from the source. So this is the electromagnetic spectrum. So radio waves, microwaves, infrared waves, and in between visible region starts from violet, indigo, blue, green, yellow, orange, red, and after violet we have ultraviolet region and X-rays and gamma rays. In these, the gamma rays are having very high energy and the radio waves are having very high very high wavelength. So wavelength and energy are inversely proportional. So radio waves and microwaves are having longer wavelength and the energy and frequency for these waves are very low. On the other hand, for gamma rays, X-rays, the energy and frequencies are very high and these are having only a short wavelength. These are all the normal usages of various radiations. In particular, infrared waves are used in TV remotes. When you pass infrared waves to the samples will undergo rotation and vibration. So in the infrared spectroscopy, we can be able to study rotation and vibration properties of the chemical compounds. So this is the typical infrared spectrometer. So infrared spectrometer is attached with a system and it can be further attached with a printer to take printout of the spectrum. When infrared radiations are passed to the organic compounds, the molecules basically undergo two types of vibrations. One is stretching vibration, another one is bending vibration. And the stretching vibrations can be further classified into two types. One is symmetric stretching, another one is asymmetric stretching. When in the case of symmetric stretching, both the atoms which are attached to the carbon goes far from the center atom at the same time, and after a moment both the atoms will come near to the center atom at the same time. This kind of stretching is called symmetrical stretching. And in the other case, asymmetrical stretching, when one atom goes far from carbon atom and the other atom will come near to the center atom. In the next moment, the atom which comes near to the center atom will go far from the center atom. The previous atom which went far from the center atom will come near to the center atom. So this kind of stretching is called asymmetrical stretching. These two stretchings or vibrations are possible while we are passing IR radiations to the organic compounds. And the other type of vibration is bending vibration. In the bending vibration, there are again two types of bending vibration. One is in-plane bending, another one is out-of-plane bending. The in-plane bending is further classified into two types. One is scissoring and rocking, and the out-of-plane bending is classified into two types. One is twisting and wagging. So in-plane bending further splitted into two types. One is scissoring, so and another type is rocking, and the out of plane bending further classified into two types. One is twisting and another one is wagging. So while you are passing IR radiations, these kind of vibrations are possible. So these kind of vibrations the molecule will undergo, and each vibrations require some amount of energy. So that energy, the corresponding energy required for that particular vibration, the molecule get or acquired from the IR radiation. So from the instrumentation part, we can able to identify what type of interaction it is, and these are all the IR radiation wavelength range. So IR radiation is nothing but the electromagnetic radiation from 0.8 micrometer to 1000 micrometer is generally called as IR region, and the IR region can further classified into three subdivisions. One is near IR, and second one is mid IR, the third one is far IR. The near IR region falls between 0.8 micrometer to 2.5 micrometer, and the mid IR region is from 2.5 micrometer to 50 micrometer, and the far IR region is from 50 micrometer to 1000 micrometer. And generally for the organic compounds, normal organic compounds, the IR radiations which are used in the IR spectrometer is from mid IR region. It is nothing but 2.5 to 50 micrometer. When you are converting the micrometer wavelength into wave number, the region of mid IR region falls between 4000 centimeter inverse wave number to 200 centimeter inverse wave number. So the wave number region of mid IR region is nothing but 4000 to 200 centimeter inverse. This is the x-axis in the spectrum. So in the spectrum, we are measuring the absorbance versus wave number in the IR spectrum. Now we will move on to IR instrumentation part. The instrumentation part of the IR spectrometer having 5 major components. So one is IR radiation source, and the second component is monochromator or wavelength selector, and the third component is sample holder or sample cell, and the fourth component is detector, and the fifth component is recorder. So we will see one by one. First, radiation source. So several radiation sources are used in the IR spectrometer, depends upon the requirement. So the radiation, the basic necessity of the basic or phenomena of a radiation source has to produce IR radiation, particularly in the mid IR region. The first radiation source is enhanced glower. So it consists of a cylinder of rare earth oxides, and the cylinder having diameter 1 to 2 millimeter, and the length is approximately 20 millimeter, and the platinum discs are attached at the ends of the cylinder to permit electrical connection. When they are heated to a temperature in the range of 1200 to 2200 Kelvin, the IR radiations are emitted from this enhanced glower radiation source. The second radiation source is glober source. Glober source is a material made up of a material used silicon carbide. The length of the cylinder is 50 millimeter and the diameter is 5 millimeter. It is glober source. And the third source of IR radiation is incandescent wire called nichrome wire. So here the nichrome wire is tightly wound by a spiral-like wire, and when electrically heated to 1100 Kelvin, it emits IR radiation. And the fourth radiation source is mercury arc lamp. The mercury arc lamp is having quartz jacket tube. Inside, mercury vapors are there. When electricity passes through the mercury vapor provides radiations, IR radiations. and the fifth one is tungsten filament, and the sixth one is carbon dioxide laser source. These are also, while you are giving power supply, it emits IR radiations in the region of mid-IR region. The next second component is wavelength selector. It is otherwise called as monochromator. So it comprises of filters, monochromators, entrance slit, collimating lens, and a dispersing element like prism or grating, and a focusing lens and a exit slit. So these are all the components of monochromator. Normally the monochromators used is having prism or grating. So the prism or grating will split the split the overall total radiations into mono radiations, like one by one it will split and pass through the slit to interfere with the chemical compounds to be analyzed sample. And gratings also used. So for the same purpose, the gratings also, it is nothing but multiple plates. So it is also having do the process of dispersing or diffracting the radiations and allow the radiations to fall on the sample one by one. And the sample cells. Normally IR radiations, all the three types of samples can be analyzed. For gaseous samples, gas cells has been used. For liquid samples, a thin film of liquid samples can be analyzed. And for solid samples, we have three types. One is KBR discs can be formed, and mull technique using Nujal oil, and deposited films also can be studied. And this is gas cells. In this, the container having locks on two sides, gas can be passed through this container and locked while inside the container. Inside this gas cell, now the sample gas to be analyzed should be kept. And left and right side, there will be a passage of possibility for the passage of IR radiation. IR radiations, when passed through the cell, it will analyze, interact with the gaseous sample, and it will record the absorption on the other side of the to the detector. And it is liquid samples. For liquid samples, so there is a liquid sample container is like in the middle part there is a gap for placing the liquid. The liquid samples can be kept inside that, and it will be allowed to pass through the IR radiation. And for solid samples, we can prepare KBR discs. The samples along with the potassium bromide can be thoroughly mixed with mortar and pestle, and the samples are loaded in the hydraulic KBR die, and the KBR die is kept in the hydraulic press and pressed to prepare the KBR discs. The KBR discs can be loaded on the instrument, and IR radiations can pass through the KBR discs, and you can analyze the samples. And for solid samples, there is another technique called a mull technique. Here, the mineral oil like liquid paraffin or Nujal oil are used. So mixed with the sample, and this Nujal oil mixed samples called mulls. That mulls are used for analysis. And for solid samples, there is another technique called solid films. So dissolving with a suitable solvent, and solid films are formed. After drying, the solid films can be studied. And detector, there are several detectors used for IR spectrometer, namely thermocouples, bolometer, Golay cell, pyroelectric detector, and photoconducting detector. These are all the detectors used in the IR spectrometer. This is thermocouple, and this one is bolometer, and this is Golay cell. These are all the detectors used in IR spectrometer. So this is the instrumentation black diagram of an FTIR spectrophotometer. Source is producing IR radiation, and it is passed through the collimator, and it will allow the radiation to pass through the sample, and thus from the sample the outcoming radiations are passed through the detector, and the detector will detect the radiation signal and convert it into a volt signal, and this will be recorded as a spectrum. So this is the basic instrumentation of IR spectrophotometer. So it is a typical spectrum. It is a typical spectrum of FTIR, and the spectrum is plotted between percentage transmittance or absorbance versus wave numbers. Already we have seen in the initial introduction itself, the wave number of normal organic compounds can be studied from 4000 centimeter inverse to 200 centimeter inverse. Thank you.